What's the difference between solving a system of equations with substitution or elimination? To illustrate the difference between substitution and elimination, I'm going to solve the same system of equations using each method. Along the left side are the steps for substitution, and you'll see that the second and third boxes illustrate isolate and substitute. And on the right-hand side, the second and third boxes illustrate match and eliminate. And those are the concepts for each method. Looking at my first set using substitution, labeling the equations 1 and 2, I can see that y in the first equation is isolated nicely already. So I'm going to go to the second step, which is to take the y value from number 1 and place it into equation 2, substitute it in. So I'm going to write equation number 2 as I see it, x minus 2. Instead of y, I'm going to write what y equals, and y equals negative 2x plus 2. So I'm substituting in, and then I'm carrying on with equation number 2. At this point, I can distribute my negative 2 into my bracket, expand, simplify, and solve. So it becomes x plus 4x minus 4 equals 6. If you're comfortable solving equations like this, you can skip a few steps. I'm going to show each one. I'm collecting like terms on the left and collecting my numbers on the right. So my variables on the left, my numbers on the right. This simplifies to 5x equals 10. Divide each side by 5. The 5's cancel out and become 1, and x equals 2. At this point, in either method, you can use whichever equation you like to solve for the other variable. I'm going to use the first equation because y is isolated nicely. So y is going to equal negative 2. X, we just solved it. It's 2 plus 2. So y equals negative 4 plus 2. Y equals negative 2. The solution is always written alphabetically, x then y, so 2, then negative 2 is your point of intersection. Moving on to elimination, we need to match and then eliminate. So again, I like to label my equations. To match and eliminate, you should put your equations in the same form so that it's easily manipulated. Equation number 1 is slightly different than equation number 2. I'm going to make them both look like the form of number 2. So equation number 1, I'm going to move the 2x from the right-hand side over to the left. So that becomes positive 2x. I'm leaving y where it is, and 2 is left on the right. Equation number 2 is just fine. X minus 2y equals 6. So now I have done the first step, which is the same on both methods. I have simplified and I've stacked if necessary. Using substitution, it wasn't necessary to do this. Using elimination, in this case, it was. So I've got it stacked, and now I need to match the coefficient, the x's or the y's. I think I'll match the x's, so in this case, I'm going to multiply my lower equation by 2. I like to write them again. And equation number 2 is going to be scaled up by a factor of 2, so 2x minus 4y equals 12. To eliminate, I'm going to subtract. 2x minus 2x becomes 0x, or 0. And y minus negative 4y becomes positive 5y, and 2 minus 12 is negative 10. Now, I typically wouldn't write the 0x. I'm just doing that for demonstration purposes. This is the line I would write. You now are going to divide both sides by 5. The 5's cancel out, and y equals negative 2. Just like in substitution, you can use whichever equation you feel you would like to find the other variable. This time I'll choose equation number 2. So I'm going to write x minus 2 times negative 2 equals 6. X plus 4 equals 6. Take the 4 to the other side, it becomes negative, and x equals 2. So my POI in this case, alphabetically, is 2, negative 2. There it is, my POI. And two POIs from both methods are identical. So the difference is just in the method, but you're going to get exactly the same result. Now here's a skill testing question. Using both methods this time, substitution and elimination. I see these on the internet all the time. So a star, a tier, and a diamond added together equal what value? So a star, a tier, and a diamond walk into a room. You see these questions again all over the internet in various forms. Determine the value of each of the shapes. So the first thing I'm going to do is to assign a variable to each of the shapes. So x is a star, y is a tier, and z is a diamond. So my first equation then becomes x plus y equals 10. The second one becomes x plus z equals 20. And the third, y plus z equals 24. To solve this, I'm going to use my substitution and elimination method. So instead of labeling 1 and 2, I've got 3 equations, 1 and 2 and 3. And from equation number 1, I'm going to isolate x. So this is the substitution method. I've got x now all by itself. And I'm going to take that and I'm going to substitute it into equation number 2. So equation number 2 becomes negative y plus 10 plus z equals 20. Negative y plus z equals 20 minus 10. Negative y plus z equals 10. So I substituted into equation number 2, and now I've got an equation with y and z in it. And this works out nicely because equation number 3 also has a y and a z in it. So I use the strategy of substitution to create another system. And now, this is equation number 2. So now I'm going to deal with equation number 2 and equation number 3. I'll put those together. So equation number 2 manipulated is negative y plus z equals 10. And equation number 3 is y plus z equals 24. Using the process of elimination now, I'm going to figure out one of the variables. I think I'll add those together because that'll clear the y's. So adding them together, the y's disappear, and you get 2z equals 34. And I'm hoping you can see that if you divide both sides by 2, you'll get z equals 17. So I'll take that information, now that I know z, and I will go into equation number 2 and figure out what x is. So x plus 17 equals 20. X equals 3. I'll take that information now and go back to equation number 1 and substitute 3 in for x, so 3 plus y equals 10. And now you can see y equals 7. So the star, which is x, is 3. The tier, which is y, is 7. The diamond is 17. Add them together, and you get 27. Thanks for listening.